Hello and welcome guys. Today we are going to learn about string construction in Java. Now, strings, there are actually two ways of constructing strings in Java. Before I go into the details of how these are different, let me first of all show you what these ways are. So, first of all, let me import the util package just in case I need something from it. It has got nothing to do with string construction itself. Let's write the main function and let us create a string. So now as you look at this string keyword, you must realize that the first letter here, okay, the first letter is capital. The first letter, when it is capital for any kind of a data type, it means that this is not a primitive data type, rather it's some kind of a class. Okay, it's a predefined class in Java. The other data types such as your int, okay, double, float, etc., all have the first letters small. What this means is that they are primitive data types in Java. But since string has a capital S, it means that it is a non-primitive data type and it's a predefined class that is present in Java. Alright? Now, we can create a string by simply enclosing it within double quotes, like this. Okay? So now, this variable is basically a string which has toy within it. But that's not the case, we'll come to that later though. Now let's create another string variable and do it in this way. Okay, let's print both of them out. S1 system.out.println S2. So as you can guess, this is a pretty straightforward program, and yeah, it gives us toy, which is S1 and S2 printed out in two different lines. So now you might ask the question, well, if there are two ways of initializing strings in Java, which is the way that I should follow? Or is there anything different between this way and this way? And yes, there is a difference between these two ways. They are not one and the same thing. So in order to understand, let us first of all draw our attention to these two variables. Remember what I said. These two variables are essentially instances of the string class, which means that these are nothing but pointers to memory locations that contain the string toy. Okay, that is S1 and S2 are nothing but pointers to memory locations which contain the string toy. They themselves do not contain the string toy, they are rather pointers to memory locations in the heap which contain this value. Alright, now let us see what happens when we try to compare these two with the normal equals operator in Java. So we see a false value. Why do we see a false value? That is because this memory location and this memory location is different, because these two are different strings, right? So the memory location for this string, the memory location to which S1 points, is different from the memory location to which S2 points, because these two are different strings. Okay, so this should make sense to you as to why S1 equals S2 gives us false. But let me show you another example. In this case, I do not use this method of initializing the string. Rather, I do this. Okay? So, compile and run it. And this time you will see that we get a true value. So what is going on? We created two different strings. These two are memory locations to these two are pointers to the memory locations of these two different strings. And so the result of this expression should have been false. but instead we get a true. So in order to understand, we need to understand the concept of string pools in Java. And here is where we will dive deeper into the into why these two different types of string initialization are different from each other. In what ways they are different from each other, that is. Okay. So I've opened up Google Jamboard here because I personally did not have any whiteboard software installed, so I guess we have to make do with this. Okay, so Java contains a heap section of the memory. Okay, within that there is a section of memory which is known as the string pool. So let's write that down. A string pool. Now what is this string pool? The string pool is basically a collection of string constants, of strings. So any kind of string. When we try to initialize a string with this way, in this way, okay, that is, we try to assign s1 to a literal string. In this way, what happens is that Java internally first checks the presence of the string in this string pool. If it finds the presence of that string, say suppose this string already existed from before, it is going to find out whether it is going to return the location of this string again. So let's see what's happening here. Let's go back to the case in which we use the same initialization method for both of these variables. So in this case, the first time when we try to initialize in this way, Java tries to find the string toy from this memory location, okay, from this string pool, but it is not able to find it because we have not previously created any toy anywhere, any string named toy anywhere. Okay, so it does not find it, and so what does it do? It creates an entry here and returns the location of this string. All right, and this gets assigned to our s1 variable here. Now what happens when you try to initialize s2 with toy using this method? What happens again? When we use this method, what did I tell? Java first of all looks whether or not the string is present inside this string pool. Now this time when it looks for it, it is able to find that there is an entry which has the contents toy. Okay, so what does it do? It returns the location of this guy again, and we can see that in our program this is assigned to s2. All right, so that is why when we do system.out.println s1 equals s2, what we get is, what we are actually doing is, we are comparing this memory location with this itself. That is, once through s1 and s2, we actually refer to the same memory location itself. All right, so naturally s1 equals s2 is true. Now let us see what happens when we make use of the new keyword. When we make use of the new keyword, we do not make any such comparisons with the string pool. What we tell Java to do is create a new string object, irrespective of whether or not it was present in the string pool. Just create a new string object and return the address of that to s2. So in this case again, if this was the heap, this was the string pool, when we execute this line, s1 equals s1 equals toy, an entry is created which contains the string toy. But when we execute this line, string s2 equals new string toy, Java does not look for the presence of the string inside the string pool. It is completely like it does not even care whether or not this presence in the string, whether or not that string is present in the string pool. What it does is it creates a completely new string in the heap section, okay, and returns the memory location to s2. Yes. So that is why in this case, when we do s1 equals s2, we do not get a true value. Instead, we get a false value. And that is pretty clearly noticeable from here that this memory location is not the same as this memory location. Now, there is another pretty interesting thing that I would like to show you all with regards to string construction. That is, if you are creating a string with the new keyword, there is also another thing that you can do. Say, this is your string. Now, there is a particular function that Java provides us, which is called the intern function. What does this intern function do? I guess many of you will be able to guess what it does by now, but in case you cannot, this is what it does. So yeah, so when this line gets executed, a new location in the heap is created which contains the string toy, and that location is returned and s1 stores that location in it. Okay, now when we call s.intern, what happens is whatever is the content of this s string here, okay, whatever was the content, which in this case is toy, that content is placed inside this string pool. All right, so let me show, and also the location of this position in the string pool is returned. So you can store it in another string, and this string, this s2, is going to actually point to this location in the string pool. All right, in order to see whether or not that is the case, let's see what happens when we try to create a string through the first method and store it in s3. Now we all know that we have created a string named toy and interned it, which means that it is actually present inside the string pool. So s2 and s3 should, in theory, point to the same location in memory, which is the location in the string pool. Let us see if that is the case. And again, we are going to compile and run and see. It is true. That is pretty cool, huh? Both s2 and s3 now point to the same location in memory. And actually what we can do is we can also completely get rid of this non-interned location s, in case, say suppose you have created a string in this way, okay, I mean through the second method, and somewhere down the line you feel like it's okay to get it interned inside this, it's okay to place the contents of s inside the string pool, and also I want s to point to this location inside the string pool itself. And what we can easily do is s equals s.intern. So what happens when you try to run this function is that whatever is the contents of toy, it is going to be placed inside the string pool, and s will now point to the location within the string pool, and the string that was actually created in the first place in the purely heap section, in the like outside of the string pool in the heap section, the pointer to it is completely lost. Okay, so yes, so these are the two ways of creating strings in Java. So let me write it down again for you. Yeah, so these are the two ways of creating strings in Java. If you do it through this way, this creates a new string every time and returns a location of a particular memory location in the heap. And what this does is it creates an entry inside the string pool if this is not already present inside the string pool. So this, in many ways, you can say that this second way is slightly more efficient than this, because this method does not actually take care of the fact whether or not the string is present in the string pool. So when you write this statement, you're guaranteed to make some allocations in memory when it is not actually needed. But in this case, you can overcome a few of those allocations, and it will be much better in terms of memory requirements of your program.